So today we are going to discuss the last topic of first unit of your syllabus, that is the use of computers in identification or in making taxonomic keys. Okay, so we have already discussed the dichotomous keys and how those keys they were popularized in the past, and most of the floras, monographs, etc., they were having the base of dichotomous keys. But then we had the keys in which we could consider number of characters at a time and without following any certain order, right? So the most advanced version of the multi-access keys, that is the use of computers. We have developed certain programs in which the characters, innumerable characters, they are listed, and according to your selection, whichever characters you tick over that program and then run the program, that will give you the result in the form of genera that can match to your specimen of identification. Okay, so this has become very simplified now. So this is a most evolved version of the multi-access keys, in which we can have the innumerable characters, whether they are available during that season or not, all of them, without any limitation that we mentioned earlier. These programs can be used, and most of these programs are free of cost. Okay, so how we use that? We have read that until recently the most popular tools for identification, they were printed keys, as we mentioned, in the form of edge punched cards, body punched cards, or die or polychotomous structure, right? Now, these were published in the taxonomic revisions, monographs, floras, books, etc. They were the popular methods which were followed. Now, such keys, they mostly do not reflect the natural classification. I told you to memorize the difference between artificial, natural, and phylogenetic classification. So natural means in which number of characters, whatever information is there regarding different whorls of the flower, regarding the vegetative structures, all that information is considered while classifying the organism. So, but whatever keys, these keys, they were used earlier, they were based on just easily observable characters, few characters. So they were the artificial keys. But we wanted to have the natural one, in which all information that is available should be used while preparing. So the natural classification based natural keys, they were not available in the past. Okay, why? Because we all know that constructing a key is a difficult task, and more the number of characters considered, complex it will become. So you cannot have the data of all characters known. For example, for a particular plant, let's suppose you are preparing key for different species of a genus, and you have enlisted total 50 characters. Now you yourself can think that using those 50 characters while preparing a key, that will be a tedious task, right? When I am giving you only 2-3 characters, then also it takes time to prepare a proper key. So with 50 characters, it becomes more difficult. So that's why it was a difficult phenomena. So usually few characters were considered and artificial keys were prepared, and they were not showing the natural classification. So the first published document that had natural criteria, that was the Lamarck's Flore Francoise. The very first key that was published for identification, that was by Lamarck. Then the conventional keys, they were used. Okay, they provided, sometimes they provided the clear impression of the genus or the species, whatever you want to look for, or sometimes a relevant information, so that you can at least come close to that group. Okay, now these keys, they were if the taxonomist is using those keys, they are comfortable, but for non-taxonomists, they were highly inconvenient because very technical methods were used. You have to move step by step. Whatever alternate leads are given, you should have information about that. So it was not comfortable for non-taxonomists. Then there was introduction of the multi-access keys, that is synoptic key or tabular key or punched cards, edge punched or body punched cards. So they were quite promising because they were easier. Okay, using those cards, it was quite easy to recognize a species. You had to match the characters with your specimen. So there were a number of attempts, but they all had shortcomings, right? So ultimately, with the development of computer languages, the use of computers in taxonomy, that started, and it started in early 60s, shortly after the introduction of high level computer languages, because we require the programs for programming languages are required. Bogue et al. And Morse, they were the first to use programs for interactive identification with a monitor as a user interface. Means now we are having a friendly, user-friendly interface. So we can put in the characters and we can get the result that okay, our specimen matches to so and so options. Okay. Now, an early example of the taxonomic online identification system. This was a popular program, Expert program, that was used, and it could be applied to various organisms, even to mushrooms and toadstools as well. So it was used for the identification. There onwards, large number of online programs, they are available for the identification of species. Now we have end list. List is never ending. You have number of programs which are being provided by various forestry departments, taxonomy departments, nomenclature boards, etc. So you can use that data, you can use that information and can easily identify your species of interest. So these are few examples. You can open these links. Let me show you. This is a program by USDA. See, you can see here, depending upon the US, they have different areas marked like Alaska, Arizona. You can open that file. Let's suppose we are opening it for Arizona. This is a zip file, so you need to extract that. Okay, the file is extracted, so you can open it. So it will open to this page called SLICS. Okay, you can see here SLICS. It's taking some time. Okay, so when you open this file, okay, this will give you the information about it. And you can run the download also. You can have all information how to prepare a file in this system. So this is how you can run this program. So I have opened one example. So here you can see it, the features they have been mentioned, that fruit is a siliqua. So you have to select whatever is character in your specimen. Let's suppose I'm having these characters, so it will give you the information about these taxa. Okay, so you can have see clearly. It will show you the pictures also. So this is how this program works. Okay, then going back to our presentation. This is another one. It's called Delta. This is also a famous program. Okay, so it will provide you with the various files. Int key is very important. This is a good one. You can just download it and place it in the C library, and from there you can run this program. I can show you. Okay, you will have the information about installing and running this program. So you can read all this. This is from where you will download the file, the zip file, and then it is mentioned here that you have to place this in C. When you will open this file, then directly the program can be run. Okay, from there you can see it. So this is one program. And we have this another multi-assess program. So you can directly go to the library for identification. Information they are providing you how to use this key. It's taking some time. Okay, so now you have this information. See, you can choose the characters directly from here. Like, let's suppose the foliage is bipinnate and we are seeing phyllodes are present. See, it is narrowing down the options. Okay, so these are the entries that have been discarded, and these are the entries which are still remaining, which are under consideration. Then you mentioned the inflorescence. It's a simple inflorescence. See, more narrowing down of the genera. Then you can mention the pod width. You have to mention a number here. Similarly, you can mention the peduncle length. You can mention if the peduncle hairs are present or not. Then if you know the distribution, you can mention that as well. Okay, we can select some more characters so that ultimately it narrows down. We have inflorescence type, globular, peduncle length. Let's suppose I'm mentioning here the peduncle length as 4. Okay, it is in mm, and pod width as 3. It is again in mm. So on. See, now you have the information. On the basis of these characters, 98 entries are left and almost 1200 have been discarded. Okay, see how narrow down the list of the genera it is. So you can easily do this. You can again repeat this one and continue. So this is because I have opened the Vetal Acacia of Australia. You can select the species accordingly. You can search for the one that you are interested in and can identify that. These are another programs I was telling you about Delta. The link has been mentioned in the previous slide also. Similarly, you have this inaturalist.org. Then we have morphbank.net, USDA, we have already seen that. So these are the open resources. You can use these resources in order to identify your species of interest. So finally, out of all these keys that we have used, we see that keys, they are most practical and utilized methods of identification, right? But they should only be regarded as guides. They should be considered as providing you an approximate information, not a perfect one. So these are not the foolproof methods. You have to depend upon other sources also. What are those other sources? Like, you can have a specimen comparison. You have a standard voucher specimen deposited in the herbarium, what we have studied as a holotype, as SIN type. So you can refer those species. You can match your specimen once you have completed the identification from a library. Let's suppose you used a key and you reached to the status that, okay, my plant is Acacia melanoxylon. It is just an example. So when you reach to this inference that it is Acacia melanoxylon, then you will go to herbarium. Okay, they have to be the herbarium of central universities or some government institutions like the Botanical Survey of India. So you will go there, you will take out the specimen which is listing Acacia melanoxylon and you will match yours one with that. Okay, then only it will be considered as the authenticated one. Or you can go to some expert and seek opinion from them. So this is how you should definitely use taxonomic keys as an identification aids, but these are not foolproof methods. So you have to authenticate your results with the help of either herbarium specimen matching or with the help of some expert. Only then the data should be considered as the authenticated one and it should be presented. Okay, so that's all. With this, we finished the unit 1 of your syllabus.